Hello and welcome to another episode of coding for Unreal Engine in C++. Hello and welcome. Today we will be taking another but a little bit closer look at actor components. We've used actor components in the past. At the very beginning we took a brief look at it, and when we made our Game of Life implementation, we've used an actor component to do things. And today we will be seeing how we can attach actor components doing runtime dynamically onto an actor, how we can access them, and what else is magical things that we can discover and do with these components to, well, finally achieve whatever we want to do. So let's get started. Yep, and here we are again. Hello and a wonderful evening to you. I hope you had a good week up until now, and the weekend isn't far. Today, the working day for today is almost over. So the only thing that parts us from the weekend is one more Friday, and Friday is basically almost Saturday. So the weekend is almost there. We can already smell it. And that's perfect. That gives us the right mood to do some nice techie and codey stuff. As mentioned in the intro, we're going to be taking a closer look at actor components again. We've used them in the past, especially when we made the Game of Life implementation, and also usually when I was trying out things, especially when we had the discussion about pointers and we were just trying out things, or on the Wednesday talks, we were just like, let's try this out quickly. I usually just made an actor component, put my code in there, slapped that into an actor, run everything, and didn't spend too much thought of what else we could do with them, because sometimes you want to put a component, a new component, onto an actor doing runtime. So the actor doesn't have the component. One moment, please. Dry throat. Need to keep that moisturized. So sometimes you want to put in a component onto the actor. The actor doesn't have the component. It's in the world, it's spawned, and everything is happy. Or you just spawned it maybe, and for whatever reason you want to have this actor another component, because this component does things that this actor is now supposed to do, but not every instance of this connector, of this actor, is supposed to do this. So we're not putting the component directly onto our actor that's been spawned, be it completely done in C++ or be it a blueprint actor. Today, to make things a bit more easy and to concentrate and to focus on what we actually want to do, we'll be creating blueprint actors and then slamming our components onto that one. And sometimes you want an actor not to do certain things. Actually all the examples today, they will be from real life examples. This will be things that actually happened, and I actually did exactly like this in our project Let Them Trade, which we want to finish eventually. It's supposed to become a game that you can then enjoy. And all these things are actually based, all the things we'll be doing, we're looking at today, are actually based on real world examples. This is also the reason why I have our actual project open in the background, and also the code. Because these are things that are actually happening in the game, that I'm actually doing there to achieve whatever I want to achieve. One example would be if we have these game tiles. And these game tiles, my computer completely crashed. Okay, this is unfortunate. Okay, this is very unfortunate. My computer completely crashed just because I wanted to start an Unreal. Oh wait, there's something happening. Oh no. Okay. Wow, I have no idea what just happened there, but my computer had a really bad hiccup. But it's back. I do not need to reboot. What happened there? Can I see something? No. CPU, GPU, all's good and well. Well, okay. For Unreal Engine to hang with depending on what you're doing, this can happen depending on what you're doing before your code exits and gives the engine time to breathe again. But the complete computer hung. Okay. Anyways, we're back. It's back here. You're currently seeing it down there. There it is in the preview, because this is just a bit summarizing where this is coming from. Because all these game tiles, each game tile is a separate actor, and you can build cities on this. And when there's not a city, I do not want this game tile to process the economy of a city. So I don't want this tile to see, yeah, well, I'm a city, I'm not producing anything, what do I have to do? I just want to act this this game tile, sorry. Having a really bad time with my throat today. Maybe it's the human, I don't know. So when there's not a city on there, I do not want it to do city stuff. But when there's a city on this, and you should also be able to see something in the log happening, which okay, things are weird today. There something starts to happen. Because when there's a city built on this game tile, stuff starts to happen. Things are doing, well, things. And I only want this to happen when there's a city on this tile. So I don't want this to happen all the time. So I can't put the component that holds the code dealing with all the city stuff. I can't put it onto the tile, onto the base actor that is spawned as a game tile. Well, yeah, of course I could do that, and then I could just put some if conditions into the code and check if there's a city, then do stuff, and if not, just don't do anything. But I don't want to do that, because mainly for performance reasons. Because if you don't plan to, most of the game tiles are empty and will not have a city. They will just exist. They will maybe have a road, so people can walk over them. But having, for each and every of those game tiles, having a component on there that's instantiated, that has to be managed by the engine, and where for every frame, or maybe even every 0.5 seconds or whatever the interval is you want to do these things to happen, having all of them fired an internal method, an internal function that then only says, no, there's no city on here, I'm not doing anything, return. At first glance, you might think, well, yeah, it's not doing anything. It's just doing the if, and if it doesn't properly if, then it returns out and everything's good. It doesn't cost you so much time. Well, true. If you only have this one actor with this one component, then this is totally true. But consider a map, I don't know, like 10 by 10 already, which is a very small map, but that's already 100 actors. And each of this actor maybe having 3 or 4 of those components that check, well, am I supposed to do something? No, I'm not supposed to do something, so I'm quitting out. So all these functions, all these components have to be managed by the engine, and all these functions are called, even if they just do one if and return back. They are called, which costs you valuable time. And again, if you're in a very, very small scale and you only have a handful actors, like with this test map, with this very, very small test map, it indeed might actually not make much of a difference. But once you have larger maps that are actually playable, this will have a huge impact on your performance. Even if this is also why in Unity, if you're working in Unity, they tell you, if you're not using the update function on your game object, delete it. Delete the update function, or else it will cost you performance, even though it's empty. And this is very much the same thing here, because this isn't a problem of like Unity. This is a more generic problem, because you're calling calling the function in itself already takes up valuable processor cycles. It takes up time. And even if this function does nothing, you have spent the time of calling the function and waiting for it to return. And if you multiply this with 100 or 1,000 or how many actors you have in your world, and then maybe you multiply this by 3 or 4, so you get like, you might end up with 40,000 components, and each of them is being called once per tick, and they're doing nothing mostly because they're not supposed to, and that costs you valuable performance. So this is why for this project I decided if something's not supposed to be done, the component holding the code that actually does this will not be present on the actor. So this is why. Okay, I got this edge thingy. Okay, still managed to eject out. So if we take a look at the component, these scene components, we talked about them, and we're also going to be talking about these a bit more today. You can see there's only 2 components. There's nothing on there, and I demonstrated this actually. I think it was on one of the Wednesday talks. When I now put a city on this, there's an additional city component that then deals with everything the city has to do or is supposed to do. Okay, something's weirdly off with my computer today. Yeah, okay. Now things look okayish again. Okay, let's see how far this goes. Maybe I would need to reboot, but that's not a problem, because the stream runs via a different computer, so I can, as long as the streaming PC doesn't do anything weird or crash, that's all fine. I can reboot this machine, and we still can't talk to each other. So yeah, this is why I at runtime put components onto the actor when I need them, and only when I need them. This is one thing we want to do, and this is one of the things we're going to be looking at today. And another thing is, sometimes you want to use a component that's on an actor from your own code, like the component has a function you want to call. Getting at the cities in this game, as an example again. The cities, they have code that process their own economy, like which resources do I produce? Do I produce any gold coins or all this stuff? And they're not doing this by themselves. They're not having their own tick that's coming from the engine. This is built in a way so that the economy manager actually has to call a specific function on the city. So the city calculates all the new economy values for this cycle. And there's another function so the city can return all its current economy data to whoever's asking for them. And also later on, the traders need to talk to the city and tell them, hey, I want to buy stuff from you. And all of that is done via methods that are methods from the component, from the city components. So what I'm trying to be getting at is the component might have functions you want to call, or maybe just values you want to access. So you have to have a way to get a reference to this specific component instance on this actor, so you can then call stuff. And this is another thing we're going to be doing. We're going to be looking at what options do I have to get a reference to a component that's on an actor, and actually the actual instance of this component of this instance of this actor. So we can then call methods on it, access values, make it do stuff, or anything like that. And the third thing we're going to be looking at, which is a bit more interesting for scene components, because there's a subtle difference. Well, it's not so subtle. There's a difference between basic actor components and scene components. We've talked about this before, and we'll quickly glimpse about this again today. And another thing we'll be doing is saying hi to UR003. Greetings. A wonderful evening. I hope you had a nice week up until now, and you're looking forward to the weekend. It's not that far. I can almost smell it. Maybe it's only my feet, but I can smell something. And yeah, and then we're going to be looking at take a look at scene components. Again, a quick rundown of what's the difference from scene components to, let's say, normal components. And the scene components, one of the differences is they can be put into a hierarchy. And well, in a hierarchy, you have parents and children, and of course you can access them, and we'll also be taking a look at how to access the parents and the children of a given scene component. And all of that based on an actual project that's actually ongoing and supposed to become a game. And so this is everything taken from the real life. So what we're looking at today will be, well, yeah, stuff that's you not only can use in the real world out there when doing games, when making games, but also has been done while working on an actual game project. So much talk. Let's switch over to the nice view where you can actually see all the interesting things that are going on. And since we want to talk about actor components, let's do that. Let's create an actor component, maybe even two, because how are we gonna do it? Yeah, we gotta see how we think, because we want to. Okay, we're gonna be making a component that dynamically adds another component. Let's try. I also prepared a bit because you can see I now got the mouse pointer. Because I'll be playing around with click events and stuff, so we can trigger whatever we want to do by clicking on an actor. If you want to know what's necessary to actually get a mouse pointer while playing, because by default you don't have a mouse pointer, you can't click on things. If you want to know what's necessary for this, spoiler alert, you need a custom player controller and a custom game mode, and we discussed this in some detail while we made the Game of Life implementation. Must have been somewhere around the first or the second part when we were working on the Game of Life implementation, where we created the base actor that was clickable. And this is basically what we're going to be doing here. So at first, let's create a new C++ class that will be an actor component, and let's decide on what we'll be doing with it a bit later on. So this will be, yeah, let's call this will be a nice name. Let's call this component test component, because we're playing around, so testing with components. And since you should always suffix your names with what they actually are. So actors are fancy super duper hero player actor. And if you put a component on this will be the super duper hero movement component or whatever. You don't have to do this. There isn't a technical reason that forces you to do this. But it's suggested and makes sense, because then when you're looking at your files, you immediately see what this is. So this is a component, this is maybe my actor, and other things. So let's see in which IDE this opens. And hopefully it opens in the right one. And actually we need to create two components, because we have one component as usual, as we've done so many times in the past. We have one component they will slap onto an actor that has the actual code that we're trying out, where we're doing stuff, because we have to have the code somewhere, so we just put it into a component. And this component will be put onto the actor, and maybe we'll be spawning I'm thinking if we're gonna be spawning new actors or if we just act on our one actor we have, but let's decide this. Because today isn't as scripted as before. This is a bit more, well, improvised. Because we're basically taking examples out of the real life and just going through them and see what we're doing there. So, oh, look at that. There's the files from yesterday still open. And okay, let's close them all because this is a bit confusing. So, here's our component CPP and our header file. Weekend is near, yes, but now it's time to train your brain. Train the brain, that sounds good. I hope a few brain cells are still there. Yeah, there's always a few brain cells left to do something. You know, worst case is we're just having a good time and maybe not understanding everything, but then there's always tomorrow where we can try to re-understand or just ask again or watch the VOD. So, but first, of course, we need to clean up and delete all those. I mean, it's always the same. I mean, if you do this for the very first time, this is quite nice. And also reminds me of this old Coca-Cola advertisement where there was this song the first time. I actually had the single from that. I actually had the song on single, on vinyl back then. Yeah, it's quite some time ago. So let's copy paste all of this because we're so lazy and say, again, because I'm so creative, let's just call this test. So this will actually be doing all the things we'll be doing today. And of course, we need to add this to the header at declaration. And we can immediately create our second actor component. And this will be the, let's call this dynamic actor component. Because we're spawning it at runtime. So basically we're doing this dynamically whenever we need, we add this. So let's call this our dynamic actor component, which will be weird because then in the browser it will just be named dynamic actor, which is a bit weird. Let's call this dynamic test component. All right. This might look a bit more sensible when we're looking at it in the editor because Unreal Engine is smart enough to know that the component is a suffix and to keep the lists a bit more readable and not to have blah component, this component, that component, foo component, bar component. It just strips the component part away and just tells you blah, blay, foo, bar, whatever the actual names of the components is, which makes the lists way more human readable. And since all the clicky lists in the editor are basically only there for us puny humans, because we need stuff like that to understand and see things, this makes perfect sense to keep them readable, but also here we need to clean up all this a bit. There's the public, and we can make this private already. Delete some surplus empty lines. Okay, this looks good. Now we have a clean slate. And there's one thing we just be putting into the begin play already. Let me just grab the UI log from yesterday. Because as you know by now, from my life, I can't remember the syntax of that. I have no idea why I have such a hard time just remembering that syntax. So our dynamic test component, because there's one very important thing that actually for me at the very beginning caused a little bit of confusion. And this is definitely something we're going to be looking at. So This is our dynamic test component begin play. And let's state this here. Hello from the begin play of our dynamically added component. So this should be showing up in the log. And remember, the begin play is called whenever, either when your actor already exists in the scene when the game starts, the begin play is called, or when the game's already running and your actor is spawned, your begin play is also called. This also goes for all the components. It's the very same. When this instance of the component, when this is instantiated and the game is running, when these two conditions are given, then begin play is called. So if this component is on an actor that you in the editor pulled into the scene and then you start the game, this is immediately being called. Or if the actor with this component on it is spawned, this is being called. Or if this is being put onto an actor and the game's already running, then also the begin play. So basically this is always called. You can make sure, or at least you think you can make sure this is always being called, but it's always being called if you do it right. If you do it properly, then it's always being called when this thing begins its life. And it doesn't really start its life while the game's not running. So it's not called when your component is instantiated, but only when the game then later is running. So I hope this made a little bit of sense. So first we're calling, of course, the parent, and then we're doing our log file hello from the begin play. So what should happen is when this component is attached to our actor, we should see this line in our log. Vinyl, oh yeah, I still have a few of them left. Don't have a player for it at the moment, but still. You're still a huge collector of it, yeah. The song on the Coca-Cola spot was from Robin Beck, exactly. Yep, first time. Yep. It was an amazing song back then. I have no idea if it's still good because I haven't heard it for, I don't know, decades. But yes, exactly. You are right. This is exactly the song I was talking about. Yep. So this should be okay for now. Or let's already wait while we're here. Let's make a test call, which also just gives a log entry that tells us the test call from our dynamically added component has been called. So this is our component we'll be adding. This also, of course, needs to go into the header. Is it where I want it? And I want it in the public section. This looks good. So now we got this little test function, and what we're going to be doing is we will be instantiating this class that essentially is an actor component. We will be instantiating this, and then we'll be adding it onto an actor. So maybe we should have an actor reference. Actor to add component, right? And of course we need to change this in the header as well because they have to match. This might be the wrong file. It's this one, okay. So because I want to keep this a bit more flexible, so we don't just add the component to the actor we are on. Maybe I think we're going to be doing this, but we'll not be doing this because our function says so. And why is this still red? Do I have to save? Oh, okay, I have to save. So we have our test function, and we give a reference to an actor as parameter here. And I'm thinking if we also, just for the sake of doing it, we will return something. We will hello, auto completion. Okay, you know, let's snag this from here. Yeah, it's UActor component. Why don't you find this? My dear auto completion, why don't you find this? Because we're actually returning added component, because we'll be running this, we'll be calling this from our blueprint, and I want to return a reference to the component we added onto the actor. I want to return this into the blueprint for two reasons. Just to show you again how it's done, just so you can see it with a practical example again how we can return stuff. It's this little ampersand thingy, exactly this. This is the key ingredient for this being the output to the other thing, the blueprint, right? So we could even, because we've talked about this recently, we can say this is an input and this is an output. Technically, it's also an input because we're basically getting we're giving a reference to the variable in that thing is supposed to write into, which, well, from the logic of it, is an output because we're giving something. Well, you know what I mean. We're also going to be doing this here. So have it neat and tidy so everyone knows what's going on. We're having the ins and the outs there. We're giving an actor in. We'll be creating a new instance of this component, and then we will return. We'll return it. Okay, cool. So how do we get an instance of this new component? Basically, like any other object as well. We need a variable to save it in, and we need to use this first, or to include. So this is our dynamic test component. There it is, exactly that dynamic test component. Because we're in the component test component and we're componenting away. So there's our type. There's our class dynamic test component, and we just call this new component. This is just a variable where we're going to be storing it in. So we can just say new component equals new object, because again, we don't instantiate classes like you would normally do in C++. We always have to use the methods Unreal Engine supplies us, because new object does a bit more. New object calls, because very, very down the line, everything basically inherits from UObject. We've talked about this. And UObject has a few things that need to be initialized, and for the garbage collection to recognize everything. So this new object, I mean, whoever, if you like, the source code for Unreal is open. You can look at it so you can see what new object actually does. But there's quite a few things it does in the background to properly initialize the Unreal object, because we're not only dealing with a simple object, we're dealing with an Unreal object. Because, well, it's Unreal we're doing here. So I can copy paste this, because this is typed. So everything, if this would have a constructor, if our component, if this class would have a constructor, we could pass it things here, but you would also break compatibility with Unreal, because it doesn't support having the constructor needing things, I think. And also, and you can also see there's the red, not sure how good you can see, but there's the red squiggly line underneath the equal sign. can you spot the problem? And if I see this, this happened to me so many times, and I think it might be eventually the same for you. This happened to me so many times that I immediately know what the problem is, because we're dealing with objects, and remember, when we're dealing with objects, all we get is references, pointers to them. So just put the asterisk there and see the red squiggly line goes away. This happened to me so many times that when I see, wait, I have this is the same type like this, and while you complain, I don't even have to look at the error message of the IDE. It's in 99% of the cases, it's the missing asterisk. But the IDE would have also told me. It tells me matches the arguments of, look, your variable is UDynamic test component, and what you're going to be putting in there is a UDynamic test component asterisk. So it's a pointer. So you know, wait, okay, it's basically the same, but this one's missing the asterisk, and since this is this one, just put that there. And everything works. If you want to know more about this, rewind to the last 2 weeks, because we've talked about pointers in all these asterisks and ampersands for 2 weeks. Well, not exactly for 2 weeks, but 2 evenings. 2 evenings we've been talking about this in excruciating detail. And should there still be any questions, I know, I've said this a million times already, ask. In the chat, in the comments, this hashtag, this Twitter handles, or those Twitter handles. Whatever is your preferred way of asking questions, choose it and then do. I cannot guarantee that I will see your smoke signals. Also, homing pigeons don't work because they always home back to you and not to me, because I don't have any homing pigeons out there. So yeah, these two won't work, but many other ways will. Lakeside, hi there. Greetings. Let's see. Oh yeah, I still got the sunglasses left from yesterday for a bit. I think they're going to be expiring soon because you only got them for 24 hours, but I still have them. And while I have them, I'm going to be using them. Cheers. Today, just water. Yesterday, I had my nice juice, and today it's just water. You have some questions you will ask for sure. Looking forward to that. Cool. So, yes, here we got a new component, and then it's time to add this to our actor. And we got the actor passed in here. So this is our actor to add component. And if we see, there is an add component, but I actually want the add instance component because we want to add the component to an existing instance of this actor. And the add component creates a new component, assigns ownership to the actor called, I don't know. I'm actually not 100% sure, I gotta admit, where the difference is between add component and add instance component. I just know that add instance component is the one we actually need. So what we do is we pass the reference of our newly created component. So look at this. We have a variable that will hold a pointer to an object of dynamic test component, and this is our variable, and we use the new object function to actually create an instance of this class, to get an object out of this class, and we will get the reference back. So here we have the pointer, and then we just pass this to add instance component, which is, well, yeah, supposed to add this component onto our actor. Okie dokie. So, quick look what the component does at begin play, and begin play is supposed to be fired all the time, every time your object becomes alive. It starts its life cycle. Begin play is supposed to be called. So here's our hello from the beginning of our dynamic component, and then we just got this little test call that for now we'll just be calling right from the blueprint where we're gonna be slapping these things on. So let's create a blueprint actor, and we call this our BP0924 because that's today, so we don't get naming collisions with another test actor we might have had before, because we're just going to be using this for testing. So open this up. And of course I have to compile first. Again, I can't put a component onto it that doesn't exist yet, because it only exists once the code that defines it has been compiled. And since we added headers, this didn't take that long. Cool. So now we should be able to add our test component, or component. Our component test component. Here it is. There it is. Wonderful. And we'll drag the reference to this out here. Again, I'm just doing a few things now, because many of these things we've been talked about already. So I'm just doing things without going into too much detail, like what I'm doing and why I'm doing this. If there's any step of the things I'm doing here you're missing, you don't understand, like, wait, how did you get this thing there? What did you do to get this blue bubble there that you can then do stuff with? And why is this there? Just ask. Just feel free to ask. I'm more than happy to go over this again and explain these things. But most of the people here today, I think, have been here for the past sessions as well. So I'll just be skimming over them, because I think most people will actually know. And but if not, just ask. So and what we would be expecting is to have the call function, I think it was called, to have the call function category here, where we can then find whatever methods this component is exposing. And because the hot reload never works, let's delete this again. And of course, I forgot to actually mark them accessible from blueprints. Here's our one. Oh, okay. Yes, we only have one function in the test component, which is our test function. And I forgot to tell Unreal that this is supposed to be able to be called from a blueprint. We do this with the U function macro in front of it and tell it this is supposed to be blueprint callable. This is exactly what I want. See, with a working auto-completion, it's very, very easy to find these things, because blueprint callable, okay, I've used this quite some time, so I know it's blueprint callable. But sometimes, maybe you do not, and maybe you're not exactly sure how it's written. So you just hack in blue, and you see there's a blueprint cosmetic. Now this is not what I want. Blueprint getter, no. Pure, setter, authority only, no idea what that is. Implementable event, the who and the what now. But here, blueprint callable. Yes, I want this to be callable from a blueprint. So this is probably the thing I want, which in this case it absolutely is. So let's recompile and hope the reload works, because it might not. Then the solution is just to restart the editor. It's not that much of a huge deal. Oh, and it told me something. Unrecognized type in. Type must be U class U struct or okay. Okay, he doesn't like these. Okay, when we this U function thingy, it does a bit more. This is very, very complicated and quite low level stuff. It doesn't like our ins and outs because this is already handled by the preprocessor. And remember, when we talked about the in and out keywords, they are also handled by the preprocessor. So they are not yet, because we just throw them out there. And everything should be fine. And Dana! Hi! Thanks a lot for 4 months and only for me. Nah, I think it's a bit for the channel in general. Dana, a very cinnamony greetings shall go out to you. And the compile is still failing. Why is that? Does it also not like... Oh, missing asterisk in expected pointer type. Did I forget an asterisk again? Oh, wait, this is one of those situations where... Oh, right. This is one of those situations... See, again, missing asterisk. And this is one of those kind of worst cases we've talked about last week. This is one of the situations where you're using the asterisk and the ampersand together at once. So this looks really confusing, like what the hell's going on there? I promise you, this was not intentional. This is why it's so important. This is why I spent 2 evenings talking about pointers with you guys. Because you see, this is so important because you're dealing with pointers all the time. Especially in Unreal, where you're basically always dealing with complex objects and references and stuff. You're constantly dealing with pointers and knowing why it yells at you and tells you, come on. I mean, it literally tells you forgot the asterisk. So you could even, just by this error message, you can just fix it without knowing why, because it tells you you're missing the asterisk and then you add it. But first you have to know where to add it. So this is why it's so important to have at least a general understanding of these things. So you immediately see, oh yeah, of course, I'm returning an object. I can't return objects. I always can return the reference to the object. So save this, and the red line should be gone, and try to compile this again. And see, this is the daily life. You change like 1 or 2 lines, and then you're going to be fighting with the compiler because the compiler tells you he doesn't like things. And trust me, the compiler is always right. The compiler is always right. He knows his stuff, and he knows when things don't work. And sometimes he even tells you. Why. So let's try this again. Let's add our component, test component. Let's drag this out and let's see if, yes, wonderful. And here we got the call function category, and here is our test method that we added. And what we want to do, we have an input. We have the actor to add component. This is the actor we want this component to be added to. For now, because we don't have any other actors, or we would need to get a reference to an actor, we just get a reference to ourself, get reference to self, and we just plug this in here. So, yeah, we're just passing a reference to ourselves, to this very actor. And also, wait a second, I think I forgot something, because isn't there a second, isn't there like a second parameter? Or is that one optional? Let's take a quick look. No. Okay. This is, oh wait. Where was that? Where did I need to pass the out? Was it here? Ah, yes. I think, well, this is confusing. Because wait, let me check how I actually did it in the actual project, because it gets the order passed for the new object. All right, okay. Because there's one little thing it does work. It will work like this, but kind of by coincidence. because this new object call, it actually, you can give it one parameter here, which is optional. Wait, did it tell us get transient package? Okay, now this doesn't make, no, from the naming you don't see it, because when you create a component, the component needs to know where it's gonna live, or the object in this case, the Unreal object needs to know where it lives. And in Unreal you have the concept of outers, because the component is kind of sitting inside of the actor. So the outside of the component is the actor. So the outer object of this component is the actor. And if we don't pass this, if we don't supply an explicit outer object, Unreal will try to find which it is, and it will usually find this the actor this code is running on. It will usually find the actor this code is running on, and will just use this one as outer object. So the component knows, okay, this is my actor, this is where I'm supposed to be living on. Even though we then explicitly add it to this actor. It's a bit of Unreal stuff. I can recommend reading the documentation there, or if you want, we can go a bit more deeper into this, what's outers and what not, on a different evening. So we're going to be passing in the actor, no, not the, yeah, the actor to add component. Okay, this is our actor we want to add the component to, because right now, this is why I said this will work by coincidence. If I leave this out, if we do this without any parameter, Unreal will automatically find this actor and give the new object, the component, this actor as its outer object. You can think of this like what's it called? An onion. Yes, like an onion. You have all these layers, and some of the inner layers is the component, and one of the outer layers is maybe another component, and one of the outer layers finally is the actor. And this is the outer layer, the outer object that's meant. And for now, in this case, it would be totally okay if the default would be used, which is this object. But since we build it in a way so that we can explicitly name an actor, like this is the actor you're supposed to go to, we also have, so that things will function properly, we also have to set, or should set, the actor that we want to put this component on as its outer object. Again, in this case, it doesn't matter, because by coincidence, it's the very same actor, but it might be some other actor we might see if we maybe we get maybe we can, depending on how much time we have left, we can put in another function here that spawns a new actor and then attaches this component to that actor and not to itself. But that depends on how much time we have left. If we might do this to demonstrate that it doesn't attach the component just to itself, but really to this specific actor that's been told there. Yeah, and that's what we did. We passed the outer component. We fixed all the pointer issues and everything else that the compiler yelled at us about. And I hope this works, because again, the hot reload tends to not work for quite a while. So what have we? We call our test function, which, or not yet, wait, now we're calling it. So as soon as this actor comes alive and starts its life cycle in the game, we call our test function that adds a component to the actor we've given it, and we give a reference to ourselves into this very actor, and we get a reference of the spawn component back. And look at this. What we could do, but I want to show you something else, and this is the reason why I'm not doing this. What I could do is, see, we're creating a uDynamic test component. We're creating an object that's of the type dynamic test component, but we're only returning an actor component. This works. Why does this work? Why can I return, why can I put a value, which I, by the way, haven't done yet? Added component equals, oh, right. Basically, yeah, our new component, right? I think it's our new component. So why does this work? Why can I put a value of this type into a variable of this type? And this is because object orientation, this is because this one inherits from this one. If you take a look in here, this inherits from uActor component. So again, this is object-oriented stuff. If you need a brush up on how object-oriented programming works, like what's a class, what's an object, what's the difference, what's inheritance, how does inheritance work, what's extending something. If that is something you're missing, because that is like super important. This is one of the most basic things you must know to be able to have a chance of understanding this, and then later on maybe actually doing this yourself. So if these are things that confuse you and you're like, well, still not getting it, do ask. I'm more than happy, maybe, I don't know, next week or whenever, depending if this is actually of interest to you to talk about this. So for now, because there's no complaints, I just consider you know what I'm talking about or what I want to say. So this is why I can put something of this type into a variable of this type, because this is an extension of this one. So this one is basically this one plus a bit more. So, and this is why this works, because they kind of have a common denominator, which is this one. What I could do is I could just return, I could actually make this added component. I could actually make this, or you know what, let's actually do this. Let's actually do this. Let's do both. Let's do both. Why not both? So I'm returning that, because then I actually can show you both and what's the difference. So let's return a basic actor component, but let's also return our proper type of dynamic test component. So, and we just call this added test component, so we can differentiate between those two. And then, of course, we have to assign this added test component is also new component. And you will see the difference, and you will also see the casting, which is actually what I want to show you. This is the reason why I use this one. Because there is situations in Unreal where quite often you're actually just getting the base class of something, especially when you have things like the game mode or the game state. There is like functions you can just use. Not sure if it's is it available for the game mode. Do I have a get game? Yeah, get game mode here. Now let's open this. We have this get game mode node that we can use in blueprints, for example, and the return value is only it's not quite good to see, but you can see return value game mode base object. You can see, okay, the reminders then I think not that interesting. So we're getting back the base class. We're getting back the base class all game objects are built upon. we don't get, if you have a custom game mode, if we have our own game mode, we're not getting a reference that is classified as our own game mode class. So you have to change this, because you know that this is supposed to be our custom game mode. And then you have to do something to just change the type. The object, the reference, and whatever's behind this will stay the same. But in the following piece of program, the program knows, okay, this is actually not this type, this is another type, and this is exactly what I want to show you. The game mode is just one example where this might happen, because the game mode is a very, very central thing in Unreal. It's something you need to access all the time, because the game mode is supposed to store your current score, your current time, whatever values define your game. Like if you have a simple space shooter, it might be your current score, your energy, your lives left, the power-ups you have picked up. All that is stored in the game mode. For as long as it's global. It might store some of these things maybe at some different place, but this is a discussion about the Unreal framework itself, because Unreal Engine not only gives you a lot of libraries and functions you can call. Unreal Engine, and this is actually one of the reasons why I like it, I also had to get used to it, and many people say, this I don't like this is why I don't want to use Unreal, or why they hesitate of actually pursuing it more. Unreal has a few things that's just telling you that's the way they need to be done, and this is the game framework. This is game mode, player controller, player pawn. All these things are set in stone. They exist, and you're supposed to use them. You can get along without using them, but you have to use them at some point, because everything starts at the game mode and the game state, and then your player controller. So it's really not a bad idea to stick to this. So this is only because why I choose the game mode as an example. So let's see, and I think this is a moment where we need to restart the editor, but this isn't a problem. So we have saved this. Hi, Eva! Greetings to you! How's the game making going? Hi there! Hope you had a great day. Long time no see. I think like 24 hours or something. Oh, it's going bad. Wow. Okay. Well, it can only get better now. It can only get better from there. So that's a plus. So let's see if I can refresh notes, and this might actually have worked. You haven't started yet. Well, okay. This is okay. Not having been started, that's okay. That's better than having started, but things just don't work. Because if there's nothing done, there's nothing that can't work, you know? So let me just fill up that a bit. Denise, hi. A wonderful evening to you as well. I hope you also had a great day. And there's Dominic. The Dominic whose question has been answered yesterday. You're not talking very much because the stream outside. No problem. Hey, no problem. You don't have to talk. You're not. It's not like when you're here, you're forced to talk or anything. You can lurk. You can stream yourself. You can do whatever you want. It's all good. Long day, but pretty good. That sounds good. That sounds pretty good. By the way, Dominic, we answered the question. I just don't know how it works. But the answer is yes. And I'm referring to the question if you can just use structs as return types. It actually works. We've tried this yesterday. And yeah, it works. You can just use structs as return types. You can use them as by reference parameters without any pointering. And now I want to know why. I have ideas how this works. I have a theory. But I think the only way to find this out is to write a very, 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 very super short program that's really only 2 lines. Compile this, throw this into a disassembler, and look what the compiler actually made out of it. Yeah. I have an idea how it works, but I don't really know for sure. But it works. It does work. You don't have to use pointers if you just use simple structs. You do have to use them with objects. We actually just had this because I forgot this. I forgot this asterisk here. And the compiler actually yelled at me, like, dude, this ain't working. You need to make this a pointer or it won't work. You said it works. I didn't say it didn't. I said I don't know. I said I had to try. So yeah, but it works. What means -R on DVD disc? There's 2 different types of DVD discs, +R and -R, and from a consumer standpoint, you really don't have to bother with this. Your DVD drive should be fine to handle both. I think all more or less recent DVD drives and burners can handle both. Rewritable is actually marked as rewritable. The minus and the plus does nothing have to do with rewritable. It's a very technical and boring difference, like how the things are actually physically laid out when the laser burns stuff into it. But from a consumer standpoint, you really don't have to bother with this. Choose the one that's cheaper, because as I said, pretty much all more or less recent DVD burners or readers, anyways, they don't care. They can handle both. Hey, Monogenesis, just looking today, which is perfectly fine. Doing some work on the site. All right. Then good luck. May your work be working at the end. So let's see if this works. So we're giving out 1 actor component and 1 dynamic test component. So because if I pull this out, let's pull out the other one first. I again don't have. I think I forgot the blueprint callable here as well. Did I? Yeah, of course. Of course, I forgot the blueprint callable. Do I have any idea on where to start with Unreal? The layout of the program is confusing for me. Yes, if you open the editor for the very first time, the default layout, is really. This is why I changed my layout to something like this. The default layout is really confusing and doesn't make many sense. Where to start? Tutorials like this one. Well, maybe not totally exactly like. Well, you could follow this step by step, because we're kind of gonna be doing things from scratch. So yeah. Well, if you have no clue, if you just open up the Unreal editor, Epic themselves, they have quite good resources to get you started. Or there's other tutorials like this one, maybe. I mean, today I didn't explain everything in excruciating detail that I did because we've done this so often and I've explained this so often. But if you rewind back to like the first episode of this tutorial series, this might give you a starting point, at least when you're trying to do C++, because this tutorial series focuses heavily on C++, not on Unreal in general. So not sure if that's perfectly suited for what you're trying to do. But there's general tutorials that just give you a head start of how to use Unreal in general. So I don't know, maybe we're going to be doing as follow-up of this series, because we have after tonight we got two evenings left, and then this series will be over for now. I don't know, maybe we'll be putting 1 or 2 evenings after this in where we just do something like an intro to Unreal in general, not focused on C++, but for people who have never used Unreal before and who just want to get their feet wet with Unreal. Just to get started, like what's what and how do I get my very first thing on the screen, and then how do I get to move it, which I think might be a good thing to start with. Is a few weeks back we made a little implementation of the Game of Life, the thing with the little cells, quite small, I hope quite easy to follow, so maybe watch the recordings of those sessions where we start the Game of Life implementation. Yeah. And if there's any, because again, this focuses heavily on C++, and we're even doing the whole actor. And an actor in Unreal is basically everything. The chairs are actors. The table is an actor. This thing, even if you don't see it in the actual game later, because there's only this magic stuff in the background, everything that exists in this scene is an actor. We've also made this in C++, which is way too much work, which is not practical, but since we're focusing on C++ here, we've done this. Una Lua for Valve Source. Yeah, I'm not sure if they actually use Lua. I'm not sure if they actually do they use Lua for Half-Life 2. Well, good luck with that. They do. All right. Okay. Yeah, I've only played Half-Life 2 once, and that's enough, and I didn't bother with that anymore. Also not that well suited with the engine, the Source engine. Well, good luck. Good luck then. So yeah, maybe watch those recordings of those sessions, and if there's any questions, just feel free to ask them. I can't stress this enough because there's only very little people actually doing this, sadly. So if you watch them, and maybe you're not the C++ guy, and maybe some of the things were confusing to you, please tweet at this hashtag or one of those 2 Twitter handles, or maybe both, or maybe use everything. Use the Twitter use the hashtag and the Twitter handles. I don't care. I'll see them, and I'll see that we get your question covered and asked. Oh, you even prefer C++ to blueprints? Yeah, then it might actually be totally your thing. Then I would actually suggest rewinding to the very first session of this series, so maybe just watch them all. They are on YouTube, by the way. They are neatly conserved on YouTube. Let me just grab the link. The bot puts it in the chat every now and then, but I don't know if there's a specific command just for the YouTube channel. So I've just put you the link to the YouTube channel of Devcom into the chat, and everything we've done here, each and every session is neatly archived and recorded on YouTube for yours to watch. So enjoy. And again, if there's any questions or confusions or things that are not absolutely clear, tweet at that, tweet at those, put it into the comments. Well, smoke signals might not work. But yeah, you get the point. There's a lot of ways to ask your question. I will make sure to see it, and either I will cover it here on the stream, or I will just see that I get you an answer another way. For that, you first need the time to go through. Too many projects. Yeah, I know that problem. I definitely know that feeling. Absolutely. So we made this one blueprint callable. Let's recompile. Maybe I should have pushed the compile button while I was telling you all the other things about the YouTube channel and such. So the problem is, did the reload? Yes! Wow! I'm impressed! Unreal actually behaves today. Look at that. If I drag from our added test component, if I drag this one out, I got the call function category, and here's my test call. Wonderful. But look at this. If I pull out the added component, there is no call function. And this is exactly the thing I wanted to show you. Because there's a little difference. Because this one is just, where is it? This one is just a reference to a basic actor component. And the second one is actually a reference to our dynamic test component. And here we are. So this one, when I drag this line out, it knows, all right, this is your dynamic test component and it has these functions, they're accessible to blueprints, everything's cool and neat, and I can call it. This one, however, does not. And let's break this for a line, for a while. So this one, because this one is only, oh yeah, wait, you can even, look at that. Yeah, again, it's a bit, the magnification doesn't quite catch it, but you can see this says added test component, dynamic test component, which is the type of this object. And this one is just an actor component object. And of course, the basic actor component object does not have our test call method. So of course, it's not available to us. We, however, know, or we expect that I need to drink something, or otherwise I get the coffees. Can't afford Half-Life 2 yet. Wait for the next Steam sale. Half-Life 2, whenever Steam has a sale, Half-Life 2 is available for next to nothing, like $2 or $3 or something. Really, it costs almost nothing. Just wait for the next sale, and there you go. So, but we expect this one. Sometimes it goes down to close to $1. Yeah, see, you only have $1 at the moment. Yeah, maybe just, I don't know. Maybe watch a tutorial and start something yourself. I mean, you said you're just starting out. You're just trying to get into making games. And I've said this yesterday. I'm not sure if actually taking Half-Life 2 as an example to learn how to make games, not sure if that's such a good idea. It might be a bit too big. So watch some free tutorials on YouTube. Choose whatever engine looks the easiest to you. For beginners, I'd actually suggest Unity. Because it's quite easy to get into. And just start with some tutorials and start with something small. Don't try to make... you have made the Skyrim mods. Okay. Oh, well, then you know a bit. Your PC can't handle UE4. Yeah, this is why I said Unity. I didn't say UE4. I said Unity. This is what I said. And this is for beginners. If you're just starting into making stuff... this is actually quite a good idea. But if your PC can run Unity, it also can run... Unreal is a bit more demanding. Yeah, it's a bit more demanding. Danny uses Unity, and from a lot of people, you've heard that Unreal is easier for beginners. Really? Yeah, depends on the person. Yeah, that's true. That's absolutely true. Depends a lot on the person, what kind of learner you are. But that's interesting. That's very interesting that many people in your bubble say that Unreal is easier for beginners. That's quite interesting. Because most of those people cannot program. So the C# apparently scares them away. Well, C# is quite easy to get into. No need to be scared of C#. And even if you do blueprints, but because this is a funny thing, even if you do blueprints in, I mean, this is very clever, because even if you do blueprints in Unreal and you think you're not programming, you think you're not really programming, you're just doing blueprints, actually the difference of using blueprints and using a programming language is quite small, because if you do blueprints, what's the actual programming magic, or what's the actual programming skill you still have to do with blueprints as well, because the actual programming is coming up with the logic and coming up with a series of things the computer has to do to finally produce the result you want. That is what's programming, coming up with the logic, with what needs to be done in what order, and where do I need to branch, and where do I need to do this, and where do I need to do that. That is programming, and you have to do this with blueprints as well. You just don't have to hack your lines of code into your program. You just say, wait, I want to get the game mode. Let me type game mode in here. And oh, look at that, I get a get game mode. Wonderful. This is where blueprint make your life very easy, because you have this exhaustive list of all the things you can do, and you just need to pick what you want to be doing. And you have this wonderful full text search where you can say, okay, now I want to do something. What's an example? I don't know. Well, we got the game mode. I want to get the game state or something. I want to get the current player controller or whatever. And then you just search for it. You just have to put in vague terms of what you want to do, and you get a neat and filtered list of things that might be what you want to do, like get player controller. There we go. And you can even tell it from which player. So this is where blueprints make your life easier. And yes, for people who have no experience in coding, they also make more sense, because you have these nodes, you have these little thingies that tell you what it is, that tell you what's the inputs, that tell you what's the outputs, and you have these neat little lines. Also, if done properly, blueprints can look quite nice. So it makes a bit more sense. You can follow the flow, what happens, a bit more easy. Makes absolute sense. But this is where blueprints make your life easier. And this is where classic programming in an actual programming language is a bit more confusing for people, because you have those lines that say technical, and this looks way more confusing than this, absolutely. But basically, there's no difference, because even the names of the nodes in blueprints have the very same names as the functions in C are calling. In the end, it's just, you have to know a comparison I like to make is, programming is like, you know what you want to say. You have the logic in your head, and then you just have to formulate this in the language of choice, be it C++, be it C#, or be it blueprints. It's similar to if you speak English, French, Polish, Russian, or whatever. You know what you want to say. Like, you want to say, hey, this is a nice day. This is your idea. This is what you want to communicate. And you only have to do this in one of the languages you speak. You can say this in English. You can say, this is a lovely day. You can say this in German. Das ist ein wunderschöner Tag. You can say this in French, which I can't, because I can't. You can do this in Russian, Polish, Dutch, whatever, which also all I can't, because I can't. But if you could, if you know these languages, you could say it in these languages. And this is the difference between programming in C++ and programming in C# and programming in BASIC or programming in PHP. Basically, there is some more fine print details, like some things in C++ actually are done differently, like in C#. There's a few smaller details, but this is basically what I'm trying to say. Yeah. So, what should you start with when starting in Unreal? A beginner tutorial. Something that starts with a clean slate and empty editor. Maybe even explains you the editor first. Like, this is this part of the editor, and here you do this, and here you do that, and here you can see this. And then starts to create the first things, maybe the first actor, the first thing you can actually see in your scene, and then gets you to how to use your keyboard or your controller to actually move these things. So yeah, beginner tutorials would be my suggestion. Again, if there's the need, because I think there's enough beginner tutorials out there. I'm not sure if there's the need for more. Because I do think there's a lot of beginner tutorials out there, and they can't all be bad. There has to be good ones as well. But should you guys tell me, or us when speaking for Devcom in general, should you tell us, guys, I've tried to find good tutorials, I failed. Not because I'm bad at looking for tutorials, because there were none that were good enough. Just let us know, and we'll make one. Because this what we're currently doing focuses more on C++, but maybe there's actually, I don't know, maybe there's need for a beginner's tutorial for people who have never touched Unreal, maybe even never touched C++, and just want to know, okay, I've opened the editor for the first time. I'm totally confused because honestly, the default layout is horrible. The default layout is really, it's confusing. I just want to know, where do I have to click to get something first on screen? How do I use the editor? If there's need for this, if you guys want this, we can do this. Absolutely no problem. Is the feel like learning C++ would be beneficial? Absolutely. If you'll be looking for a job in the future. Absolutely. Absolutely. C or C++ for that matter is still the pillar of everything. Without C++, everything else would not exist. Without C or C++, nothing else would exist. So knowing C++ is definitely an advantage. And just be it to understand things in other programming languages, because even the quite abstract ones like C#, where you're really high level and you don't have to deal with all the low level computery stuff. But knowing C++ gives you some understanding of the basics that are happening under the hood that will make your life with any other high level programming language more easy. So knowing C++ definitely a plus. You may literally no beginner tutorial mentions how using mesh colliders can destroy your performance. Yeah, because it's beginner tutorials. That's perfectly fine. Mentioning that in a beginner tutorial is too much. Because in a beginner tutorial, at least in my opinion, you first have to get people going at all. So they get their first thing in their scene. And maybe they can even control it via keyboard or even gamepad or something. And once you got the base covered, once you got the basics and the people are comfortable and say, yeah, okay, I can do this, but now I want to do it well. And I want to know where's the problems, what possible problems can. Then you can tell them all the issues that you might run. Like one of the issues, and I think I've mentioned this quite sometimes in this tutorial series, is this one. This, depending on how many actors you have and how many components you have on your actors, that what I just highlighted there is one of your main performance suckers, especially if it's empty and does nothing. That can be a problem. Your problem is always error 40. Okay? I have no idea what that is. And explain little details like that which will ruin your experience. Well, again, for later. First, have an experience at all, because you can't ruin something you're not getting to at all. But if you... the problem is 40 centimeters of the... Oh, you mean layer 8. Oh, I see. You mean the layer 8 problem. Yes. Okay, now... Okay. Yeah, now I got it. Yeah, that's the same with me. My problem is usually, if you put it like that, it's the error 40 or the layer 8. That's usually the problem, yes. And yeah, there are plenty of tutorials, but you feel like if you guys are doing a beginner one, would be really good to start with basics and then do little details that are not that well known. Yeah, we can do that. That's a pretty cool idea. I passed this. Yeah, or in German, the DAO. Yeah, the stupidest user you could possibly have. Yeah. Der dümmste anzunehmende User. The most stupid of them all. The layer 8. It's always the layer 8. So where were we? Yes, we were right here. And we didn't have the test call. So, but we expect that this added component, we expect this to be our test component. So what we can do is, and let me just type oh look, I didn't even have to type that much. And this is the beauty of blueprints again. I know I want to do something with my dynamic test component, and there I already got it. We do a cast. We did a cast in C++. I think when did we do the casting? Did we do casts in the game of life? I'm not sure, but we did that. So we can cast this, which is basically we're changing the type. The object we're having here stays the same. We don't change the actual object. We just consider it's of a different type. And if it's actually not this type that we want, we have this cast failed, where we can then, I don't know, maybe give an error that says, okay, I was expecting to get my dynamic test component, but I didn't. Because this cast actually checks. It doesn't just give you this object then as the other type you want to have. It actually checks if this is possible, if whatever this object is actually can be referenced to as this type. In our case, we can be pretty sure that it is. So now we can take this one, and here we should have our call function test call. Wonderful. And move this to there, break this, move this. See, and this is my problem. This is my problem with blueprints. Because I always want them to be neat and tidy, and I hate crossing lines. I hate lines that cross themselves, but I think I have to. Or no, I don't. Okay, we actually do this call first, and then we do this call, and then we tidy up this line a bit because it has to look good. Yeah, this looks neat, doesn't it? This looks neat. So, what we're expecting now. What is the expected result of this? I'm expecting 3 lines in my log. The first line is from the begin play. Because remember, the begin play is always called when an object begins its life cycle while the game is running. So I'm expecting this hello from the begin play out of this hello. I'm expecting this one. And then I'm expecting 2 lines of this test call, because we're calling it 2 times. We're calling it once when we actually, when we cast it, we have just an actor component. We are casting this to our component type, and then we're calling the test call. And then we're calling it again from when we actually really got it as our own component type. So that's the 3 lines I'm expecting. And let's, in case I forgot something, let's compile this once more. And then let's, because this is another layer 8 problem I'm quite good at running into, because if I run this now, we get nothing. There's again, I've used the warn. I made those log entries into warnings, so they show up in yellow, and you can see there's no yellow here. There's nothing. And this is my most common fault, because I didn't drag my test actor that I have all these neat little things on and that's doing stuff. I didn't put it into the scene, so well, can't run. So now it's in the scene. Now I run it, and look at that. We do get 2 lines of code, of log entries. We do get the test call from our dynamically added component has been called twice, which is for this log entry exactly what we expected. But there's one missing. There's one missing. There is from our begin play, that one's missing. And begin play is quite important, because in begin play, you set up the initial state of your object, in this case our component, because you might have default values, like the starting budget of a city. Like in the real world example where I took this from, if you build a city, like this city has a starting budget. It has some amount of gold coins it starts with, so it can start buying stuff. And these defaults are usually set up in the begin play method. So this one not running can be a problem. This can be a huge problem, because begin play is meant for your initialization code to go to, and you don't have to care about this. I could make an init function here, and I could call this. But why? I don't have to. There's this begin play, and the begin play, you see this everywhere, all over Unreal. You see the begin play. It's for those of you who know Unity a bit. It's the start function. It's what the start method in Unity is, and this is quite important, because everything you need so your object can actually properly do whatever it is it's been doing. The begin play is quite important. So why is this not firing? Let's try. Hey, let me copy this log thing. And let's put it into the begin play of our test component. This is the one that's actually attached to our actor. Great tutorial. You're missing episode 1 of the tutorial. Is it down? I'm not sure where you've looked. First of all, a wonderful evening to you. Nice for you to stop by, and I'm very happy. Glad to hear you like it. If you looked at the VODs of Twitch, it might already be gone, because Twitch only stores VODs for so long. But we do have a YouTube channel, and let me grab you the link of that, because there episode 1 should be absolutely available. Devcom Tutorials 1, 2, 3. See all. Yeah, episode 1. There it is. At the top, where it belongs. Perfect. So there's. I just put you the link for the YouTube channel into the chat. And there, all sessions All sessions we made here are archived there forever for years to watch. And there's the very first episode where we just started off a bit. Then we started a bit more, and then we started with the game of life somewhere here around there. Well, yeah, there's something. I think the titles will even be. Oh yeah, look at that. The titles are already been updated. Oh yeah, wow. They are all already updated because up until shortly it was just Devcom Tutorials episode 1, episode 2, episode 3. And now look at this. This is intro for C++. This is actors and components. Then our 3 parts of our game of life. Then the first part of us talking about pointers. I think the second part about pointers will be live shortly, and eventually all this. So yeah, pretty much, no, not pretty much. Exactly, all sessions we made here are conserved on YouTube, no matter what Twitch thinks about keeping things stored. So this is our component test component. And we call this is where everything starts. Because why not? I don't know. So this is the begin play of our component test component. And this is the one that's actually attached to our actor. This is the one we've put onto the actor in the editor. It's always there. And we're dynamically adding this test, the dynamically test component. And we should check if it's actually there. But first I'm going to be saving all of this and recompiling. So we might get the log entry from this. And we start it. Okay, and now we are not even getting that begin play. But no, we do. Okay. See, this is the problem. You don't know if the editor hasn't reloaded it properly. But look at this. We got our first. This is where everything starts. This is the begin play from the component we've attached onto the actor in the editor. It's always there. And then we got the 2 calls from the one we added dynamically. And let's see. Where's our actor? This is the test actor, and let's see if the component is on there at all. And yes, it is. Look at that. We got our component test. That's the one we added in the editor. And we got the dynamic test component. This is the one we added at runtime via code. And now we got the problem that of our dynamically added dynamic test component, the begin play isn't called. And this actually has been a problem. I've actually run into this problem. This is why I wanted to show you this. Because we forgot one important thing that at first glance might not be intuitive. What we did is we created an instance of our component, and then we added this component to our actor. And as we've just seen in the editor, it worked perfectly. The component was there. And we could call methods from this component. Everything handy dandy, everything nice. But yet the begin play didn't fire. Because there's one thing missing. Because we have to call, and I think it's on the component. The component itself has a method register component. And we have to call this one. Now we're done. This one is very, very important. This one is super important, and it's not really intuitive, at least not in my opinion, because we created our instance and we added it to our actor, which is fine, which worked. I mean, the component was there. It was attached to our actor. We could call methods from it. Everything worked. But yet a few things were missing, because when we've done this, this is the setup basically. This is set up the component on the actor. And this is actually tell the component we're done setting it up, and it can let the engine add can do needed init stuff. So, because for an actor component to properly work, it has to do quite a few things. The component has to register. Well, this is because it's called register component. Because the component has to register itself with the engine. The component has to tell the engine, look, I'm here, I exist, and I'm finished, I'm done. Not in the sense that it's done doing what it's supposed to do. It's done in the sense, I'm ready to go, I'm ready to rock, where's the party? So the engine then knows about this component, and now the begin play should fire, because now the engine knows, there's a new component on this actor. We are in game. The game is running. This component just started its life. So let's do all the things that are necessary to properly initialize components and get them going. And calling the begin play method is one of those things. So save this, compile it. And given the reload works, which it didn't, so compile again. This is, yeah, okay. But again, this is, did I still do something wrong in my code? Or did the editor just not reload my newly compiled code? This is a bit, so if things don't work at first, if you change, this is also very important. This is pretty much as important as the register component. If you've changed something in your C++ code of things you've already instantiated in the editor, like your actor is already in the scene, or you have a component that's already on an actor that's in the scene. You've changed something in your code. You compile it, you start the game, and nothing changes. Don't worry, it might not be your code. Compile again, a second time, without doing anything. Just hit the compile button once more and run it again. And there's a quite good chance that now it will work. If it still doesn't work, and you're quite sure it should, because adding a simple log line shouldn't be that much of an issue. That's not rocket science. Also try to restart the editor. And see if it works if you restarted the editor. Compile your changes, close down the editor, completely restart it, and see if it works then. Because the Unreal editor, it's, I think since version 4.17 or something, it has huge problems of reloading and refreshing things that have been recompiled. Because the things the code we're writing here is code that's actually already instantiated. It already exists in this system. It's instantiated. We have instance of the objects. So what the editor has to do is it has to replace the versions of all these things with the ones that were just compiled, and this fails since a few versions, and for some reason they don't get it fixed. So yeah, this just as a side note. If things don't work, compile again. If they still don't work, but you're pretty sure they should, restart the editor completely. And if it still doesn't work, yeah, then it's actually a problem of your code. And Dadla, hi, greetings. For a wonderful evening. So yeah, but now look at this. Now we actually got everything we were expecting. We get this is where everything starts, because this is the begin play of the component that's directly attached to the actor inside the editor. Then we get our hello from the begin play of our dynamically added component. because now, because we call the register component, it's properly initialized and the engine knows about it, and the engine can handle it properly. So the begin play is properly called, and then we get the 2 test calls. So this is very important. If you at runtime, or like I like to call it dynamically, add components to your actors, do not forget to call the register component. And this is one trap. This is one trap I've actually stepped into recently. This was when I was working on the cities in our game, because they didn't quite work. The tax rates were just always 0, and it didn't work, and everything was messed up. And it was like, why? Look at this. I'm setting those values. I'm doing this. Like I'm having this log output there, but it's not showing up. Until eventually I figured out, yeah, okay, I forgot this register component, which is quite important. So this is why I wanted to show you this. So if you add components to your actors at runtime, don't forget this line and enter save. So basically it's 3 lines, at least. Create the instance, add it to the actor, and then register that damn thing. Hey, Hobbitsburg! Greetings! Hi. A big hello to all there. Yes, a big hello back to you. Hi, I hope you're fine. All those drawings recently, those drawings were so amazing. I was so like, wow, it's amazing work. Just by the way. So now we got that. Now we got a component added and everything's cool. The next step, the next thing I want to show you or to try with you is, because sometimes you want to do it the other way around. Sometimes you know there's a certain component, or there could be, because there also could not, right? You know there's a fair chance that a certain component might be on this actor. Again, a real world example, the game tiles in our game, they might have a city or they might not. So if they have a city, I want to get the city component so I can interact with the city, like buying stock, selling stock, and all the stuff. So the next thing we're going to be trying to do is, and this is why I create another method, and we call this test2. And this one, and we also give it an actor. We also, yeah, I guess we demonstrated the outputting thing up here. I don't think we need to do this again. So we just give this the actor, and of course have it added to the header. This looks solid. So we have an actor that we're gonna be, let's call this actor with component. And we want to get our component, our dynamic test component. We want to get this from the actor. Of course, in this case, we could just pass the reference through, but this is only for some demonstration. So there's situations where you only have a reference to the actor, and that's it. There's nothing. This is all you get. And you want to be accessing one of the components that are attached onto the actor to then, I don't know, call stuff. Those of you who already know a bit from Unity might absolutely exactly zero be wowed or surprised, because if you know Unity, you already know what we're going to do. And yes, it pretty much works exactly the same, just the functions might be called slightly bit different, but not even that much. So What we want to do is we want to get our dynamic test component, and let me not forget the asterisk because we're only getting a reference. So we call this the component, right? We call this the component. And we have our actor. We have our actor with components. So what we can do is there's a very handy, where's my, oh, maybe I should not mistype it. Find component by class. Let me just peek into the other project if that's actually what I'm looking for. Yes, it's find component by class. It's exactly that. Because there's so many. Let's just search for something component related. There is so many methods available, like get components by tag or snap root code. I don't know what that is. Or just get components, or did I write this properly? Component. Yeah, of course not. Component. Jesus Christ. So there is, look at that. There is get component by class. There's get component, get by tag, and then there's finds. There's find components by class. So there's a lot of options you have. And you're more than welcome to check out the documentation of Unreal. It's very scarce, but maybe you can make out some of the subtle differences. I think these are also not templated. Yeah, this is the difference of get component by class and find component by class. Because as you can see, the get component by class just gives us back a reference to a uActor component. The same thing we just did in our little blueprint return test there. This gives us just a reference to the base class, and we have to cast this ourselves into the type of our component and do stuff. And this one's templated. This is a bit more convenient to use because you can actually tell this one. You can, well, like this. You can tell this one, look, I'm looking for this one for this dynamic test component. You also give this the get component by class. You also tell it, yeah, I'm looking for a component of this. But this one also takes care of the typecasting. So what we're getting back is nothing, because we're not saving it somewhere. We should put it like in there. So what we're getting back is a reference to this component, but already properly cast and typed to our component. So we don't have to do the casting, which is quite convenient. If you want to do it by hand, or if you want to do some other things, some other magic, you can do this. Then you use the get component by class, which only gives you an actor component, and then you have to typecast it to whatever component you're actually trying to access. But this one already takes care of this. So this is very, very convenient. You just use this. And also, warning, performance-wise, this is extremely expensive. This is extremely expensive performance-wise. So if you can avoid calling this, avoid it. What you usually do is when you want references, or when you need this reference several times, you just grab this reference once, and then you save it in some variable like here, which actually will then be maybe a property of your class or whatever. And then you cache this. You store this reference you get into some local variable. So whenever you need, especially when you call this in the tick function, because some people want to access component stuff from the tick function that by default is called every frame. And if you, in every frame, you do the find component thing, your performance will just tank. It will drop down to the point where you get seconds per frame instead of frames per second. So if you do need this, get this reference someplace else, maybe in the begin play if you can, or maybe in some other function. Whenever you have the chance, get this reference once, save it in a local property of your class, and then in your tick function only access the property. So you don't have to call. So TLDR, call this as few times as possible. Whenever there is a way to avoid calling this, use this way. Your performance will be thanking you. When you have more free time, you would like to learn Go or Rust. Which one would I recommend? I cannot answer this question because I haven't used Rust myself. I like what you did there, changing FPS to SPF. What? Just stating the facts. I haven't used Rust myself, so I can't answer this. I have been told by people who do know both languages, at least good enough to be able to say something about it, that they are very, very similar. I personally only have experience using Go, and that one I can totally recommend. I like Go. I really, really like. You see, I even have a Go project open here in the background that at the moment gives me quite a headache. But that's nothing. That's Go to blame. That's the programming thing I was talking about. Like, remember, like an hour ago when I said programming is actually coming up with the logic with what your program is supposed to do in what order. That's what currently is giving me the problem there. I like Go a lot, and I have no idea about Rust. So Go I would definitely absolutely recommend. If you want to choose between Go or Rust, I think you just have to try both and then see which one suits you. Maybe there's subtle differences that make it for you. Maybe you say, well, they're kind of both the same to me. If you plan to ever be working for Twitch, if your future plans involve working in the development department of Twitch, then you should learn Go, because the Twitch machine. Not sure if it's still the case, but it used to be mainly Go. Everything in the background that makes Twitch twitching, at least some time ago. I'm not totally up to date on this, but it used to be all done in Go. Yep. Yeah, sorry that I can't be of more help there. So what we did here is we called the find component by class, and we're actually getting this neatly back, and then we can call stuff. We can say the component test call. Again, you know what? Let's make a second one, or we get confused while we have. Let's make a second one. This is test call 2, and this is the second test call. Look at that. We're so creative. It's amazing. So, and we also, I'm not sure if you want to, but come on, let's make this blueprint callable. It doesn't hurt. It really does not hurt. So, we are calling test call number 2. I'm now thinking, should I deliberately have this running into a crash when I show you something else, or should we just talk about? Now we should just come on. We talk about this right away, because some of you might now ask, okay, cool. You want to find this component from the actor, and then you want to call stuff from it. But what happens if the actor doesn't have this component? Because right now, We can be pretty sure that it has, but what if we do not call this test method? Then we're not going to be having this component added. So what happens when there is no such component that we're looking for? These are not the components you're looking for. All right. This is actually very, very easy because find component by class returns null when it didn't find anything. And we can test for this. We can just say if the component is not equal null, or let's even say null pointer, because that's basically what it is. I hope this works. This should work. I think in the past I actually always put just null in there. I think I did it like this. And then it's telling me, it's already telling me 0 constant can be replaced with null pointer. Yeah, exactly. Yeah, let's try this. This looks neat. This looks like we know what we're doing. So if this component does not equal to a null pointer, then we call this thing. But we want to tell ourselves that we did not find this function. So we put another ulog in there. And this tells us, whoopsie, did not find our component on that actor. And you know what? Let's make this an error. Let's make this a proper error, because then we actually see something in red and we immediately see it worked or not. So what we're doing is we try to find the component that is based on this class. And if we were successful, which means the component now does not have a null pointer, we're calling something from it. Otherwise, we're just putting into the log that, yeah, failed, we didn't find that. So let's, stop the currently still running thingy. You know what? I'm just going to be compiling it 2 times. So we don't even have to worry about maybe it doesn't work on the first time. Does my fancy mode still work? No, yes, haha! It still works, I hope. So, compile again. Oh, and look at this. There's the link. The bot just flushed the link to the YouTube channel into the chat. So, all right, we are not calling. Okay. We're not calling it. Now this is our added test component, but this is actually a call from the component test. So let's drag this in here once more. Let's say call function. Where's my test2? Didn't I just? Nay, wait. No, that's okay. It's not the hot reload problem. Didn't we just? Oh, yeah. Okay, I see. I forgot. I put the blueprint callable at the one where it's not needed, but completely forgot it where it's actually needed. So yeah, blame on me. No? Error 40, layer 8. Again, the user strikes back. Compiling, yes indeed, I'm compiling. Compile complete. All right. Play? No, not play. It's getting late. I'm getting confused. Hellcat is using confusion. Confusion is very strong with him. So here, this is our test 2. Actually, to add component. Whoa, wait, did I? Oh, yeah. Aha, oh, this is okay. This is funny. Oh, this is interesting. Why didn't my IDE complain? Look at this. I have a different name for the variable in my actual CPP file than in my header thingy here. Yeah, let's fix that. Okay, I hope this works now. Please, Unreal Editor, be with me, not against me. And again, we're compiling. Isn't there like, I don't know, some nerdcore artists, do they have a song like I'm compiling? Compiling. Call function, test 2. Actor with component, yes, wonderful. So let's make this neat and tidy and get the self reference again, because we are testing ourselves with this. Cool. Let's run this, and we can see wonderful. We have the second test call from out there, yada. So this is the one. So what we've done is we just called this test2 function, and this test2 function made our, where's our actor? Here's our actor. Made our dynamically added, also by runtime added component say this is the second call, because this is where it is here. This is, I'm not lying. This is the dynamic test component. This is the one we're adding, and here's the test call 2. So that worked nicely. We got the component, so we were able to call a method on this component. And this is how you can do it if you have your actors floating around and you have components on there that do things, and these components offer you methods to, I don't know, do stuff. Maybe you have a component, again, real world example, I have a movement component in our actual project. Yeah, anyways, there's a movement component, like the traders, when there's the traders that are moving around. There's a movement component that handles this actor is now moving its way, and in this case, the actor itself gets a reference to this movement component to then tell the movement component, look, no, actually it's a different component on the actor. There's another component on the actor that takes care of the actual trader logic. And once that has decided to which city it wants to travel, it fetches a reference of the other component, of the movement component, to tell it, look, I want to go there, please do. And we can just check if I kept to what I just said, if I cached the, where's my, I have to check this some other time. But because maybe I might have actually still calling this find component by class for the movement component. I actually might be calling this every time I want to move somewhere. I'm not sure if I actually cached the reference, which I totally should do. The YouTube with the coding train have a jingle that call never forget the this dot because it's JavaScript. Oh, JavaScript. Yeah. Yeah, JavaScript. Don't get me started. I think we've talked about this so many times already. So now let's try what happens, because look, we are adding the component in this test method. We call this test method, and this test method adds this component onto the actor, and yeah, registers it, and everything's cool. So let's not do this. Let's not call, first let's stop everything. Let's not call this test method, but let's call this one instead immediately. And let me tidy up this line a bit. Oops. let me just tidy up this line a bit. So this looks nice and straight, doesn't it? Yeah, okay. So what we're doing is now we're completely skipping all of this. We're completely skipping this. So by not calling the test, these are not so important because these just were the calls of a method on the component that we got returned here, just to demonstrate this. Now we're passing by all of this. We are not calling our test method, which means we will not have. Wait, before I compile this, I should be able to start this with the old version. Oh no, it already. This is interesting. It auto compiles when you. Okay, let's drag this in there again. So this is what we've done so far, right? This is what we've done so far. We have all our log entries like we expected them to be. And if we look at our test actor, we also have our dynamic test component attached to it because that is what our test function did. So let's not call this, let's bypass this, not call the test function. So we should not get this thing added and just immediately call the test2, which tries to get a reference to the component and then call something onto it. So compile, save, and run. So, and you can already see that here in the log, of course, we got that this is where everything starts. This is the begin play of our initial test component. But then when we call the test2, we actually get this proper error message. Whoops, did not find our component. Because if we now look at the actor, this is our actor, and we look up here, we have our component test. This is the one we added in the editor. But it's missing the other one. It's missing our dynamic test component since we didn't add it. And this is very important. And this is called error handling. And this is something a lot of people, I don't know, forget to do not want to do, for whatever reason, they are not doing it, which is bad. Because let me comment this out. Let me comment all of. Okay, let's make this a bit more easy. Let's actually, use C++ start comments here. So let me comment it out. Unfortunately, what many people do is, they are very sure that yes. I know that my test thingy there is called first, and I'm pretty sure that I do have this component on my actor. And so I get the component and then I call whatever I want from the component, which is fine because the component actually offers these things. And now I'll be doing a save all, and you will notice why. Because I compile this, and I already compiled it twice, just like before, just to make sure. And I run this. Oh. What? This was supposed to crash, by the way. This was totally supposed to go up in flames. But interestingly, and I had it crash before. When I had null pointers, I had it crash before, and it crashed because of the good old null pointer exception. But it seems that I don't know. it seems to know that this is a null pointer, and then it's just ignoring this call. It's just not executing it because this is null. Let's put this. Oh, it's already at debug. This is nice. It's already debug game editor. Let's close this and restart it in debug mode. And let's set a breakpoint here, because I want to look at this. Expected to be first header include what? Oh, I did something wrong. Expected component, test component thingy, whatchamacallit. Oh, like so? That's interesting. Why didn't it complain before? Where are Unity and Unreal different? Wow, that question is actually more complex than it might sound. You mean like workflow? Oh, okay. That makes it more easy. That makes the answer way more easy. They are not so much, actually. They are not so much different. Actually, most of the things, if you know Unity, you will find it quite easy to get around in Unreal. Because many things work the same as they do in Unity. They just have different names. Like, if in Unity you're very comfortable and you can work with you having your game object and having your components on the game object, you will kind of immediately understand all the actor stuff. Because an actor in Unreal is basically what the game object in Unity is. Except for you can make it a bit more stuff. A game object in Unity is basically just nothing. A game object in Unity only does things because you're adding components to it. And an actor in Unreal is basically what the game object in Unity is, but also can do things on its own. The actor can have own code that does things, which in Unity, as far as I know, game objects don't. In game objects, you have to put components on it to do anything. So this is a minor difference. This is nothing game breaking, because if you just don't put any code in Unreal onto it and you just make everything in components, which is actually exactly the way. Well, not exactly. We have a bit of stuff going on in the blueprints, which can be considered code. But yeah, basically, the actor is your game object, and the components are your components. The component system works workflow-wise pretty much the same like in Unity. So there's, from the way you work with it, almost no difference. And the same goes for some code things like these ones, like the find component by class. The Unity function has almost exactly this name, or maybe it even has this name. So there are surprisingly many things. There are surprisingly many things that are very, very, very similar. That are so similar that if you know them in the one engine, you'll be having almost no problem getting the hang of that in the other engine. The differences are, well, render pipeline wise, which I don't have to deal with that much because I'm the backend, I'm the coding guy, I'm the guy who does all the C++ things, and everything that's having to deal with render pipeline and all that and the shader stuff is done by our artist. But I want to get into shader coding, but actual shader coding, not shader graph stuff. I actually want to get my feet wet with actual shader coding, like really, what's it called? I don't know. There's the name you make shaders in has a special name. I actually want to get my feet wet with this. I really want to do this because I'm still dreaming of taking part in the live shader compo of Revision. Yes, I really want to do this. I really want to take part in the live shader compo of the Revision Easter Party for those who know it. And if you don't know it, you definitely should go there. It's amazing. The differences are in the details. The differences are mostly in the details. The biggest difference is the game framework of Unreal. That's the stuff with game mode, player controller, player pawn, and these things. Then, well, you could also translate this to the game objects because you have some pre-made things you can build upon. Like you have a pawn. A pawn is an actor plus something more. Then you got a player, which is a pawn plus something more, and so forth. But you could do this with game objects in Unity as well, just slapping more components on it. Yeah, the difference there's also I think it's better answered by there is actual guides out there. I'm not sure if I'm not sure where it is. There's guides out there that actually really compare Unreal and Unity. Like, where's the difference? Or there's guides, Unreal for Unity developers, that actually show you, like, okay, this is how it's done in Unity, and this is done how it's done in Unreal. This is actually a series I wanted to do, but specifically made for YouTube then, where I show things how they are done in the one engine and then how they're done in the other engine, so that people trying to move from one engine to the other, they can just see, okay, this I know, okay, and the engine, okay, and there it's done like this. But yeah, the differences are in the details. If you're comfortable working in the one engine, you're having a quite good time. You'll be getting used to the other one quite easily. The biggest difference being that Unity uses C#, which is very, very forgiving. You can't really you can't really destroy things using C#. The worst thing that could happen to you is having a red error message in your log, while Unreal uses C++, which is very, very unforgiving. One little mistake in C++ can make the whole engine crash. Yeah. So this, I think, might be the biggest difference. The languages, because, as I said, C# is very forgiving and very user-friendly, has a lot of safety nets, and things can't really go really, really badly wrong, while in C++, one bad pointer and the whole thing crashes. So, which is what I wanted to see. Look, I push here and I check there, and it's null. Yeah. Can you see that? What I just did is, I just started our little test game again. I just hit the play button here, which eventually goes to the test2 method that tries to fetch the component. And the component, this is the nice thing when working with a debugger, you can actually peek into variables what's in there. And I don't even have to peek in there because it's telling me right here the contents of it. And the component, it's just null. And this is very interesting because calling a method from a pointer that's literally null should result in the good old null pointer exception, which is exactly that. You try to dereference and access something from a pointer that's null, which doesn't work, which goes kaboom. And this one seems to be clever enough to just ignore it. To just ignore the call. That is very interesting. It will crash if it's not. This might have to do with how C++ objects work, because C++ objects under the hood are very, very complex beings. There's a lot of going on with these things under the hood. So this is not this call in plain C. This would actually be a memory address that you were jumping to. With C++ objects, this works quite complex, and I have no idea how. I just know that they're quite complex beings. I never spent the time to actually figure out how they work, how the mechanics under the hood work. So, but it's clever enough to know, okay, you're trying to call a method from an object, but you don't have a reference to the object, so it's just ignoring this call. So surprisingly, it does not crash. It also doesn't do anything, which is pretty much as bad, because it doesn't do anything. So instead of a crash, your program starts misbehaving, and you have no idea why. You're expecting this, hey, I want the result of my component function. I want this to be here. I want this to do something. And it's not happening. Why it's not happening? Wait, where's my code? Here. I'm calling this. I'm doing this, and all's good. So yeah, this is still bad code, even if it doesn't crash. Just because it doesn't crash doesn't mean this is the way to do it. So please always add when it's needed. Always add error handling. Always check for the null pointers. If you're accessing something and you can't be an absolute exact 100% sure that this thing exists, and you can't, because this call might fail, no matter how sure you are that yes, my actor does have this component, it might not, for whatever reason, because something might have gone wrong here already, which didn't crash. Why is this red? Huh? Why is this red all of a sudden? Has no member test. What? Okay, because now this is... Oh. Because I need to move... Alright. I need to move this include. I have no idea why it didn't complain earlier, but I have to move this include to here. Now it should work. Why is this yellow now? No. Huh? Wrong one. It's this one I need to move. Yeah, it's getting late. It's getting late. You can see that. I'm using confusion. Confusion is very, very strong with me. You will never be able to max out any engine, so mostly for you it comes down to workflow and overall usability. Exactly. Most of us will not be able to really use any engine to its full extent, because these things are so powerful. These can do so much. For me personally, but this pretty much boils down to what you just said. It comes down to where I feel the most comfortable. What working with for me, feels nice. What I like, and I personally enjoy working with Unreal Engine way more than I do with Unity. There's actually some real hard complaints I have with Unity, why I try to avoid Unity and do as little as possible with it. I'm not saying I don't have any complaints with Unreal as well. I have some things that I complain about, or that annoy me with Unreal as well. I'm not saying Unreal is the bestest and the perfectest. Absolutely not. There's things I complain about with Unreal as well. But There is some really, at least for me, some people don't mind. For some, it's even okay. For some, see, the reason why I like to avoid Unity for some people is the reason why they like working with it. Do I sharing some of those complaints? Yeah, my biggest complaint is in Unity, before you can do anything, you have to install a crap load of third-party plugins from the asset store. Because Unity by itself offers you close to nothing feature-wise. It's just the bare minimum. Unity has just the bare minimum so you get your first squares or spheres moving on the screen. And for so many things, you need to code them completely yourself, or you need to install a bucket load of additional third-party plugins from the asset store, which I hate, which is the worst, the absolute worst, because you're not only making yourself you're not only depend on the one developer that's making the engine, you also make yourself dependent of 25 million, or this is a bit exaggerated, but of many other third-party developers, and you have to trust them that when there's an engine update, they will keep their plugins updated so they work with the most recent engine update, or else you can't update your engine. Or if there's a bug in this plugin, it doesn't work like it's supposed to, you have to hope that developer is still supporting that thing and will fix this bug. So you put yourself at the well, yeah, you're making your not sure how to phrase it, but you're dependent of so many other developers to do their job and to maintain their plugins. And this is something I really do not like. Unless you can be 100% sure that these things are maintained. If the plugins are well maintained and you can be absolutely sure, like there's another example, like in the web development world, when you work with PHP, there's a framework that's called Symfony. And you also have many bundles or packages of other developers that make up the whole framework and give you all the functionality you need. But those are usually very well maintained because sometimes they are done by companies. So the companies take care of, or at least very dedicated people and developers who have maintained their packages for eternities. It's still not cool. I don't still like the idea of being dependent of so many other developers. So this is my main complaint. And Unreal offers you almost everything you need. There's so much that Unreal comes with out of the box that you just have to use. It's just there. So yeah, this is my biggest complaint, and this is the biggest reason why I like to avoid Unity. But again, this is only my opinion. Other people like this. Other people, like one guy I'm actually working with, he's actually part of our team. He says, no, this is super cool because Unity is very sleek and it only has the bare minimum to get you going, and then you only install the things you need and nothing more. So that's his point of view, which is totally valid. It's just not my point of view. And therefore it's good that both engines exist because they serve different tastes, different people. So everyone can have what they like most. Another complaint I have with Unity is let's really start. You have your computer had a completely empty hard drive. You just finished installing Windows. So there's nothing on your computer that interferes with anything. And now you install Unity. a fresh and clean install of Unity. And the first thing you get is a huge log of error messages when you start it. Why? The engine is broken. You start the engine or the editor, fresh install, empty project. And the first thing you get is a huge log of error messages. And then you do things and the errors get more. And even if you got rid of all the errors, eventually when you hit the play button in Unity too often, you're flooded with errors. Your CPU spikes to 100% because it can't handle all the error messages flushing into the log. Because Unity, I don't know, forgot that itself exists. I don't know. You close the editor, you restart the editor, and it works again. This is kind of annoying, but as I've mentioned quite some times tonight, Unreal has a similar problem. When you compile your code, it might not manage to actually refresh all instances of your objects with the new compiled versions, which can have the wildest effects. So you have to close the editor and restart it. Unreal is not perfect. I just like it more. The worst example I had of this reload problem, I've written a component and I had put it onto an actor and I had configured stuff and everything. And the reload didn't work anymore. And also it completely messed up something. Also closing the editor, restarting it, didn't make the component working anymore. Each time, so I tried to delete the component. I was like, okay, no problem. Let me delete the component, save everything, close the editor, cleanly open it up again, and then add the newly compiled version of the component. I couldn't delete the component. Every time I tried to delete the component, Unreal crashed. I couldn't get rid of the component anymore. I tried to delete it and the thing crashed. I actually worked around this by completely emptying out the class. So the component was only just a completely empty class. Compiled this, which at least enabled me to delete the component. Then I could paste the code back in, compile it, re-edit, everything worked. Yeah. Problems like this Unreal does have as well. So yeah, so these are my biggest complaint. Also, Unreal just looks nicer. I mean, let's face it. If you drag something, I mean, look at this. You drag something into your scene. Let's say, let's do some. Can I wait? Where was that? I could select some material that thing immediately spawned with. How did I do that? Well, anyways, you can pull the box in, and then we can go to our starter content, to the materials, and grab the wood, for example. Like this one. Or maybe drag another. Okay, this is okay. I have the material selected here, and then I can just drag the boxes in there. Unfortunately, I don't have a proper lighting now. Maybe I need more light. So, are these BSPs, by the way? Yeah, these. Yeah, that's the BSPs. All right. Yeah, I need proper lighting. I need a light. I need a point light. Yeah, let's. Oh yeah, this look. Oh, look at this. Look at this. I've done nothing. I've just pulled in a default material from the starter thing. Put a light on top of it, and you can you see? I'm not sure if you can see this well enough in the stream, but you can already see here these grooves in the wood, and it just looks out of the box. Unreal just looks a bit more nicer. And also my artist at work, look at this. This that just looks gorgeous. Oh, here you can see it. The normal maps are just amazing. And even my artists, I mean, it's not only me, it's even my artist at work who says, yeah, working with Unreal, because, I mean, the artist is the guy who is responsible to make things look nice and shiny. And with shiny, I mean not glossy, I mean really nice. And he says, yeah, working with Unreal makes it so much more easy because things just look amazing out of the box, and then you can build on top of that. And of course, you can achieve this look in Unity as well. I'm not saying you can't do this with Unity, but it's a lot more work to get this result in Unity. Yeah, and for me, it's also a personal thing. My decision between Unreal and Unity is also a personal thing. I just like Unreal more. There is no technical reason for this. It might have to do with the past a bit, because the first time I touched Unreal was with Unreal Engine 2 in Unreal Tournament 2003. So I got a bit of history with Unreal, and I don't know, I just like it. But yeah, well, there you got it. We got the last half hour filled with this, because actually we are kind of at the end with this. There's a few more things like with we got scene components, and scene components can actually be put in a hierarchical order. Let's show you this here. Yeah, that's it. Oh, I even have it open already. No, but this is wrong. This is not what I want. Okay. Let me wait a second. I show you what I mean. Environment. No, where is game assets? Do you see? This is when you don't know your own structure and your own project. And let's, I don't know. Let's take the forest. Why not? So this is the forest. Flop. If you look at the component list here in the bottom, at the very bottom, so much at the bottom that even the magnifying thingy gets to the border of the screen. Well, I guess you'll be looking for tutorials more. Yeah, that's how I started. That's how pretty much everyone started. Tutorials always a good thing. And again, if you have any questions, feel free to ask. Maybe I can answer them. Twitter hashtag, Twitter handles, the comments on YouTube, or the chat here the next time we meet. If there's anything, I don't know, unclear, confusing, anything, just yeah, ask it, and we'll see that we get it answered. That's why we're here. So you can see these are the components, just like the components we just worked with. And this is basically only list. In this case, the list is quite short. It's only 2 components. But if there were more, it was just a flat list. And if you look up here, this gets a bit more interesting. And oh, this is okay. Something went wrong here. Okay. I need to clean up this a bit, because some of these are childed to where they. This one's right, but this one shouldn't be here. This one should be 1 level up, including its child. But that's not a problem. This is easy to. It's just drag and drop, literally. But I wanted to show you is you can see you got this static mesh component. If I get these tooltips under control, you see this static mesh component, and this has this hexagon thing as a child, and that again has a selection material thingy as child. So scene components work a bit differently to our normal components. Our normal components are just blocks of code that we slap onto our actor, and then either they do something by themselves, or they offer functions you can call to do something or to have them do something, and that's it. Scene components, to begin with, they all have a transform. That's the biggest difference between scene components and air quote normal actor components, because scene components have a transform, which is this thing here, up here. Location, rotation, scale, all of this. That's the transform. This is where the thing lives in the scene, because scene components are always, they always exist in the scene. They are there. Even if they don't have anything to show, because they don't have a mesh assigned to them or stuff like that. They exist. They have a position and a rotation. They have a transform in the world space. They exist as something in the world space, and should they happen to display something, you can see them. Should they decide to not display something, you can't see them. So there's many, and this is the confusing part, because there's many scene components that you don't see, because they don't have visible things. They don't have visible components like a mesh component or something. This is the biggest difference. They exist in the scene, and therefore they have a transform, and they have a hierarchical order. Our normal actor components, the ones we've worked with so far, when you slap thousands of them onto an actor, you just have a flat list. And you have no way of, or at least I think, let me try this. But I don't think you can't put them into hierarchical order, but let's try this. Now that I tell you, where is my blueprint? Where's my blueprint? No? My blueprint's gone? Where's my actor? There's my actor. Why don't I see it here? Oh, because I still have the filter on. Yeah, layer 8 again. It's getting late. I still had the filter on. So, of course, that's why I didn't see it. So here's our test actor from today. And I don't know, let me add the component test just a second time. And I am not able to drag this as a child of the other component. Well, you won't be able to see much but you see the red circle with the bar through it. So it actually tells me the selected component is not a scene component and cannot be attached to other components. So our normal code components are just that, a flat list of code buckets that are attached. They don't need to be childed, but the scene components, as you have seen here, the scene components actually have a hierarchical order. You can't put one as a child of the other. And this also means that when you're handling them in code, you can actually get this whole tree, and you can see that give me the parents of this, and you will get these two. Or this one can say, give me all my childs, then it gets this one. So there you got a hierarchy that you can work with, that you can put them into. Yeah, this is the second big difference of scene components, because they are usually supposed to be something that you can see. In this case, this selection material thing, there's actually only code on there. There's nothing. The effect of what it does is visible, but basically this could have been a simple code component. The reason why I put this as a selection material, as a scene component, is actually because I needed this hierarchy, because this component needs to know who's my parent, who do I belong to, which is this static mesh. And this is why I made this a scene component, because it's actually using the hierarchy. It's actually looking up who's my parent. So you are my parent, okay? So I'll be doing things to you and none of the other scene components. It only affects this one mesh. Yeah, so this is actually using the hierarchy. I can show you the code if I find it. I should find it. There should be, sorry, my hex field components. There should be a selection material component. Here it is. So let's close the ones down here so I have more space to actually see something. And there is some place I'm getting, you know what, let's just look for parent. No results. Okay, this is interesting. Okay, I'll dig this out for later. Oh, I'm the wrong. Ha! I'm in the wrong. I'm in the wrong file. I could have sworn I double clicked on this. So let's look for. Ah, here we go. Look at this. There we go. Begin play. So this is the variable where I'm holding all the parents, and then you actually just got to get parent components. So it's quite easy. Sometimes these things are so surprisingly easy. You just say, hey, come on, give me all of my parents. And then you get them in reverse order. So you get the nearest parent first, and then the next one, then the next one. And one thing I'm doing, I'm using this to set the component tick enable to false, because this is what I mentioned earlier about performance. Disable the tick when you don't need it. And here I just brutally make sure that everything in the path has its tick disabled. Because we don't need it. So this saves quite a lot. This really saves a lot of performance. I actually tried this. I didn't do this. I made a huge map, 100 by 100 pieces, without this. And then I added this and I compared, and there was a significant FPS difference. Yeah, and this is basically it. You get an array where index 0 is your closest parent, index 1 is the parent of this one through the whole hierarchy, and it's of type. Oh no, I'm casting this to static mesh component because the types of this, you can see this here, the types in the array are just scene components. This is why I showed you this before. This is why I showed you this, because in Unreal, you usually, when you use the generic functions, you always get the base object, the base class, like scene component, actor component. You usually do not get the actual type of what it is. Can't be, because otherwise this code would be, you would make one function for every type. So they keep this a bit generic. They use the interface or the base class everything extends on. So I'm then casting those to static mesh components, because I know this is what I'm looking for as a static mesh component. And then again, checking if I got something valid back, if I'm not getting a null pointer or anything. So if this worked, if the cast worked, and I got something, I got a working reference back, then I do stuff with it. So yeah, this is also a quick noting of scene components. They work quite differently. Yeah, they are the same but different. You can put code in there, they can do amazing things, but they behave a bit different. They basically do a bit more. They do a bit more than our normal actor components, because they have the transform and they have the hierarchy there and stuff like that. So there's that. there's also the scene components. Glad we could at least a bit talk about them as well tonight. If you have questions about scene components, like show us something with scene components, let me know. Because otherwise we'll be doing other things. Next week, and yes, this sounds like this evening's over, and this is exactly what it is. I will now leave you into your well-deserved night. It's not that late. There's still time for one or two episodes on Netflix before finally heading to bed. Before then heading to the last working day of this week tomorrow. Yes, which we'll do. And I need to get this spam thingy there out of the bot. If it does it once, it's enough. So, yeah. This was it for today. We talked about actor components, how to use them programmatically, how to at runtime add them, how to get references to them, and how to work in general with them. At the end, we had a quick look at scene components and how they are a bit different from our normal code components. So next week, yeah, this is what I just was about to say. Next week, I will be here only on Thursday again. As far as I know. Because next week on Wednesday, the Game Dev Show with Stefan and Deborah is supposed to be back. So I will be then here on Thursday again with the second to last episode of this tutorial series. Next week, we will be talking about something else that we can do in C++ for Unreal. And the week after that will be the 10th and last episode for now, where I will be we'll be looking back at everything we've done. I will be just looking back and see what we started with, take a look at our game of life again, and just revisit the things we've done the past 9 episodes. And I would really like if you would have some questions, because I would actually like to do a Q&A in that episode to answer some of your questions. They don't necessarily have specifically to do with this code. Anything you think might be be suited for that evening. So yeah, we'll be revisiting stuff, and then we have to see how this continues. Anyways, I wish you a wonderful night. Thank you for being here and spending your valuable time with me there for the questions you put in the chat and everything. And well, yeah, just for following this through, being here with me, for your comments and everything. And let me see. There's the saddest button of them all, because that's the button that ends it. But, you know, all good things must come to an end. But we'll see. If you want to, next week, Thursday, 6 p.m., this channel, this time, this day. Have a good night. See you around.